Hello! In this video I'm going to show you how to balance some equations. So here's some chemical reactions and we want to balance them out. So what I always do is I start with complicated compounds. Complicated compounds. Okay? So first I'm just going to highlight the most complicated one in each. What I think is the most complicated. I might be wrong, but I'm just going to find what I think is the most complicated. And it's hard to tell with that one. I think that one. Okay, now I might be wrong, but let's go with that. Okay, so I want to do those ones first. So let's start at the top one here and zoom in. There you go. So first, I would generally start with the metal, make sure that they're balanced. But I see over here that it's easy to balance it. So I'll put in a 2 for now. 2 makes it balanced, but let's look at the other part of it. So there's 1 ion, 2 ions. Sometimes you need to break it up, but for now you don't. Look, like this one, you can tell that there's a SO4 here, and SO4 over here, so it should be good. So we need to have 3 SO4s on this side. Okay, we have 3 SO4s. So now this balances. This is 1, but you don't write the 1. So how many H's do we have over here? We've got 3 H2s, 3 H2s. And now they're balanced. So sometimes you'd have to go back and then fix this aluminum, but if I'm looking here, aluminum is still balanced, so we're good. Fantastic. Good to go. Now let's look at the next one. We've got the most complicated one I highlighted here. Let's take a look at PO4 first here. This one. Hey, everything's popping up today. Okay, PO4 here. So, is there enough PO4s on this side? Yes. There's 1 PO4 here, and there's 1 PO4 here. Let's look at the next molecule, or next ion. So this one here. NH4, 3. Okay. So, I need to make sure there's 3 on this side. So there's now 3 of those on that side. Okay, looks good. Now, what I do is I follow the equation around. So I just went from this whole bit to this whole bit. Okay, so start here and then follow the compounds. So what I mean by follow the compounds is I looked at the PO4, it was already done. And then I need to finish off this molecule here. So to finish off, I had to look at the ammonium, the NH4. And so I looked at this NH4, balanced them. Once I balanced them, this original molecule is done. So now I hop to the second molecule that I was just working on. Okay, this one. So now I need to look at the second part. There's the OH here. So how many OHs are there on this side? 3, because we just multiplied in. Now this coefficient is multiplying in. So let's make sure there's going to be 3 on this side. Okay. 3 OH, 3 OH. And now we follow. There's an H here. So we follow, again, we're following what we just started off at. Okay. So we went from this one first, then we went to this one, then now we're at this one, and we're looking at H's, and if we look over here, we've got 3, and we've got 3, we're good to go. So there you go, we're done. Okay, So, actually I just deleted something. There you go. Let's look at the next equation here. This one, they all look pretty much the same difficulty. Like they're all the same complicatedness. But let's follow it across. OH is already good. Okay, so OH here is equal to the OH here. So let's look at the potassium. Potassium here compared to the potassium here. Well, I need to multiply this one by 2 to get 2, because now they have both have 2. Okay, now I look again at the other part, because I now multiplied this by 2. Now the OHs are not equal. So let's balance out the OHs. Okay, and now, just like before, now we hop to the next compound that we just talked about. So the OHs are accounted for. So let's just look at the H. Okay, we're just looking at the H here. We're just looking at the H here. Then how many H's do we have? We've got 2 on the one and 2 on the other. Good. How many sulfurs do we have? Now we're hopping. Finally, we're hopping to this equation. How many sulfurs do we have? 1, 2. So we're done. Okay. Let's look at the next equation here. Our most complicated one that I chose was NH4, 3, PO4. Okay. So let's start at the more complicated, whichever one looks more complicated, whichever ion looks more complicated. Since there's this 3 here, I'm thinking that it's going to be more complicated. Okay, so let's start with the ammonium and look at the other place on the right side of the equation where ammonium is. Here's ammonium. So there are 3 on the left, now there's 3 on the right. Simple as that. Let's look at the PO4. There's 1 on the left, and there's 2 on the right. Okay, so now we have to change this to 2 to equal this little 2. Okay, but now we have to go back and check the ammonia. How many ammonias are there? There's actually 6 of them now. Okay, so this is equal here, 2 and 2, but ammonia has 6 on the left, and we had this at 3, but now we have to change it to 6, because now we have 6 ammonia. Okay. Now we have finally finished the highlighted one, and we're done the ammonia. So now let's look at this chlorine. How many chlorines are there? Well, there's 6 now, because we now multiplied by that coefficient. Now on this side, here, how many chlorines are there? There's only 2. We need to have 6. So 3 times 2 is 6. How many zincs are there now? There's 3. And there's 3 on this side. And we are finito. So that's how you do some balancing of equations. Basically, all it is start with the complicated compounds, and then you go to, so starting here, and then you follow / hop around with the compounds. And another rule of thumb is just a rule, like you don't have to follow these rules, but they're suggestions, is if you see these 3, you always go carbon first, then hydrogen, then oxygen. It's just another rule, but you don't need to follow it. If you get the answer, otherwise it's good. These rules are just supposed to be helpful. So, helpful, I'm going to call them guidelines, not rules, guidelines. Okay? However you get the answer, doesn't matter, they're just suggestions. I hope the video helps, and you practice lots. Good luck.